So today we are going to be dividing rational expressions, which is almost identical to what we did yesterday. It just adds one extra step. So when you divide fractions, if we said 1/4, I'm not going to do 1/4, I'm going to do 1/2. If we said 1/2 divided by 1/4, the way that we would do this problem is we would do keep it, change it, flip it. So keep it, change it, flip it. We would keep the 1/2 the same, we would change it to a multiplication problem, and then we would flip the 1/4 into 4/1. And then once we did that, now it's exactly like the problems from yesterday. At this point, we are just multiplying the two fractions together. So now, once we're multiplying two fractions together, we just remember that from yesterday, we multiply straight across. So multiplying straight across, we get 1 times 4 is 4, 2 times 1 is 2, and 4 divided by 2 is 2. And if you're someone who does any like baking or cooking or anything, if you said 1/2 cup of flour divided by a 1/4 cup, how many of those would you need if all you had was a 1/4 cup to measure? 1/2 cup divided by a 1/4 cup, you would need 2 of those. 1/2 divided by 1/4 is 2. So it makes sense. It's a logical way of doing it. But what we're going to remember for today is that when we're dividing rational expressions, we're dividing fractions, we do keep it, change it, flip it, we turn it into a multiplication problem, so it's just like what we did yesterday, and then we just multiply straight across. Now, just like yesterday, we're not going to have simple problems where it's just numbers. We're going to have problems with parentheses and factors and things like that. And so we're going to have stuff canceling out and simplifying as we go. And so we'll do that first, and then we're just going to write down our leftovers. So I'm going to go ahead and start off just by writing down some problems for you guys so we can practice these together. So for our example problems, the instructions are going to be the same as what they've been every day. The instructions are probably just going to tell you to simplify these. And then for this first one, we're going to have x minus 5 times x plus 2 over x plus 5 times x plus 3 divided by x plus 7, x plus 2 over x plus 5, x minus 3. All right, so what are we going to do? It's a division problem, so how do we start? How do we start it? Keep it, change it, flip it. So anytime we see it's a division problem, we're going to keep it, change it, flip it. So keep it, change it, flip it. Almost Kentucky Fried Chicken, not quite. So keep the first one the same. change it to a multiplication problem, and flip the second one. Okay. And if we were multiplying before we simplified, we would just take everything that's on the top and write it on the top, everything that's on the bottom, write it on the bottom, and write it as one fraction. But it'll be easier to cancel some stuff out before we write our final answer. So do you guys see anything that could cancel out? X plus 5, X plus 2, anything else? Nope. So this answer has more things than we like, probably. So I've got an x minus 5 on the top and an x minus 3. And then on the bottom, I have an x plus 3 and an x plus 7. So lots of stuff left over. So there is my final answer. Okay. This next one says x squared minus 1 over 4x divided by x squared minus 5x plus 4 over x times x plus 4 times x minus 4. So we shouldn't cancel anything yet. It's a division problem, so before we cancel anything. Say that again. Oh, okay. This right here is a 4, yeah. And what do we do very first thing? Keep it, change it, flip it. Since it's a division problem, so I'm going to do x squared minus 1 over 4x. Change it to a multiplication problem. And then I'm going to flip this fraction upside down. And they factored some of it for us, but they didn't factor all of it for us. So we've got a trinomial right here. We know with the trinomials, those are the x problems. So we're looking for something that multiplies to 4, but adds to negative 5. Negative 4, negative 1, perfect. Okay, so I know the second fraction has the factors, the top we already knew, but the bottom is x minus 4, x minus 1. Anyone know how to factor the top of the other fraction? X squared minus 1? What type of factoring is that? It's not GCF. What's the other one? Square. Yeah, it's the perfect squares. 1 is a perfect square. It's just like a really simple one. So that means we're going to have 2 sets of parentheses, one with a plus, one with a minus. And what goes in those parentheses? X plus 1, x minus 1. Perfect. Okay. So what cancels out? Okay, x minus 1, x minus 1, x minus 4, x minus 4. And one more thing. Just the regular x. X and x. We couldn't cancel out the 4, but we were able to get the x out of there. Okay. And nothing else, because there's a 4 here, but this 4 is in parentheses, so they can't cancel. Okay, so we are done. Now we just have to write what's on the top of a fraction, and then what's on the bottom of a fraction, and we'll be finished. So x plus 1, x plus 4 over 4. Done. Okay, let's try one that's got more GCFs instead of the X problems to factor. So we're going to do 42k squared minus 48k over 6k times 3k minus 5 divided by 28k squared minus 32k and then 4k times 3k minus 5. So we're not doing the x because it's only 2 terms. 42 and 48 don't look like perfect squares. They're GCF. So I'm going to make my calculator help me. I'm going to take my calculator. I'm going to hit the math button. Before I hit 9, I'm going to go over to number, then I'm going to hit 9. I'm going to have my calculator help me find the GCF between 42 and 48. And what is it? 6? It's 6, okay. All right. But before we do that, I almost led us astray. Before we do that, this is a division problem, so what do we got to do? Keep it, change it, flip it. Okay, so I'm going to write that down first, and then I'll do my factoring. And the reason we always do keep change first before we do our factoring is that if you start doing your factoring first, you might forget to keep change flip, and then you might actually cancel stuff that can't cancel. And so it's always good to do the keep change flip before you factor. Okay. So we just found out that the GCF on the top is 6. What else is the GCF on the top? K. Okay. And then once we take out the 6K, what is left over? Seven K minus 8. Okay. The bottom stays the same. What's the GCF between 28 and 32? 4? 4 and what else? Is it just 4 or is there a letter also? Okay. And then what's left over? 7k minus 8. Okay. All right. And then what cancels? 6k, 6k. 4k, 4k. 7k minus 8, 7k minus 8. They all cancel. So is the answer 0? The answer is 1. Okay, when everything cancels out, the answer is 1. Okay. What a complicated problem if you just want the answer to be 1. All right, there's the next one. And I think this is probably going to be our last example problem. It seems like you guys are understanding it. So it's a division problem, which means keep, change, flip. Okay. And then what do we do? So we're looking for what multiplies to what, adds to what? Multiplies to -5 and adds to -4. -5 and 1, okay. Over here, multiplies to -21, adds to 4. Okay, what multiplies to -21 but adds to 4? Multiplies to -21, adds to 4. You're very, very close. 7 and 3, but should the 7 be the negative number? The 3 is the negative number. Okay, so we got k minus 3, k plus 1. Over k minus 5, k plus 1. Times k plus 7, k plus 1. Over k plus 7, k minus 3. Okay. So what cancels? K plus 7, K plus 7, K plus, K plus 3? K plus 1. Now, do I cancel out all 3 of the K plus 1s? No. What do I get to cancel? Yeah. Do I get to cancel a K plus 1 here and a K plus 1 here? I can cancel. They can't be both on the top. So when I cancel them, it has to be 1 on the top, 1 on the bottom. It doesn't matter where they are on the top. I could do this one on the top, this one on the bottom, or this one on the top, this one on the bottom. But they have to be a pair on the top and the bottom, only 2. I can only cancel 2 at a time. So I'm going to cancel 1 on the top, 1 on the bottom. That leaves 1 behind because there was 3 of them. K minus 3 is a pair. We're going to cancel those, okay? So our final answer is K plus 1 on the top and K minus 5 on the bottom. Perfect. All right. So only difference from today versus yesterday is we got to keep, change, flip to turn it into a multiplication problem before we get started. Now, similar to yesterday, a lot of the beginning problems are factored for you. And then when you get to the end of the assignment, you have some problems you've got to factor yourself. But most of the first ones are going to be pretty quick since they're already factored. You cannot flip in your head. The flip part has to be written down. Got it? No flipping in your head. So if you don't feel like writing all the work, you don't have to rewrite the first fraction. If you just want to like scribble out the second fraction and flip it over and then do all your canceling, that's totally fine. But you do not get to mentally flip it and not write it. Does that make sense? We write the flip down and then we do our canceling. Yes. All right. Did you want to go after her? Yeah, that's fine. All right. Somebody needs to go check out. Does anyone know who it is? It sounded like Daniel, but it sounded like last name Lily.
What?
It sounded like Lily. I know it's not any of your last names. Hold on, let me